Good morning, children. Welcome to your chemistry online class. Last class, we have discussed about the so many gas laws, and we have solved problems also based on that, and we have seen that ideal gas behavior. So, it is the next topic is very important, that is kinetic molecular theory. You have only a brief. You have to study only a brief idea about kinetic molecular theory of matter. So we'll see what is kinetic molecular theory of matter. It is a theory to describe all types of matter, that is gas, solid, liquid, etc. It's a theory of all matter. Mainly it is focusing on gases. So based on this theory, it states that all matter are in a constant state of motion. The theory is used to explain the properties of solids, liquids and gases. But mainly it is focusing on the gases. So so this theory having five assumptions are there. Mainly five assumptions are there. Assumptions means if you are formulating a theory, there will be some assumptions. That is it is not a real concept. Scientists will give some their ideas. We call it as assumptions. So the main assumptions of the theory are the first the first assumption is gases consist of a large number of tiny particles that are far apart relative to their size. So here it is considering the gas particles are very small and they are in very large number and very tiny, and we know the distance between two gas particles are very high, very large. So this is the first theory. These all are, we know all those things. Then the most of the volume occupied by a gas is empty space. Accounts for low density compared to solids and liquids. The second one is collision between gas particles and between particles and container walls are elastic collisions with no loss of energy. We know if you take gas particle in a container, they will collide each other and they will collide with the wall of the container. So, but as per this assumption, they are saying the collisions are elastic. That means we know after collision what will happen. If we collide with any other person, our movement will change or our pressure, everything will be changed, isn't it? Similar to that, if two particles will collide each other, their temperature may be vary, their movement will be vary, their speed will be vary. Such things are there. But according to kinetic molecular theory, it states that after the collisions are elastic. That is, there is no loss of energy. So after the collision also, the movement, the force, the energy, all will be same. This is the second assumption. Then third assumption is gas particles are in constant, rapid, random motions. We know gas particles are collide each other. So and there is no much attractive force or fixed shape in gas particles. So they will move always a constant, rapid, random motion. We can call it as Brownian motion or etc. So any moving particle which show what type of energy? It's kinetic energy. So hence it possesses kinetic energy. So the fourth assumption is there are no force of attraction or repulsion between gas particles. Why? Because if we take gas particles, they are far apart. But in the case of solid, each atoms are arranged nearby. So one atom or one molecule or one ion touching each other. But if we take gas particles, we know there is a certain distance between one particle to another gas particle. So there is no option for much attraction or repulsion between gas particles. So as we said earlier, they will possess kinetic energy. So we know the kinetic energy formula is Ke is equal to half mv square, where m is equal to mass and v is equal to velocity. So if we take gas particles, we cannot calculate the kinetic energy of one particle. Thus we are taking the average kinetic energy. The average kinetic energy of gas particles depends upon the temperature of the gas. If temperature increases, the kinetic energy also increases. All gases have the same temperature, having same kinetic energy. If you see here, the average kinetic energy of gas particle depends upon the temperature of the gas. So the kinetic molecule, these are the assumptions. So the kinetic molecule theory applies only to ideal gases. But as we say, we have discussed earlier that ideal gases are there and all, but it is only a theoretical concept. In the practical concept or practical world, there is no existence of ideal gas, because gases can behave nearly to ideally, because in high, if they're high pressure or very low temperature only, it can possess that. But in the normal temperature and normal pressure, no gases will possess this ideal behavior. So we'll see that. So we'll see the deviation of gases from ideal behavior, how they will deviate, why they are deviate, and all we'll see.